All right, welcome back to the channel. This is episode 3 of these AIP DevSides. What we're working through is parsing SEC filings. I've got the Palantir 10Q loaded up in here. And last episode, I showed you how to base64 encode the pages as images, so you can use those in computer vision use cases, which we're going to walk through today in code authoring, code repos. How you can go ahead and use API orchestrators to make calls to these commercial models like OpenAI's GPT-4 with Vision, and also just GPT-4 in a controlled way, so you don't like max out your tokens, and you can retry if you get rate limited, et cetera, et cetera. This is a library that Palantir created called AIP Orchestrators, and that manages all the hard parts of scaling pipelines that include these models, because if you don't do that, you won't ever get anything done, right? And you have to be able to take advantage of Spark executors and a whole bunch of other things to integrate LLMs at scale. So we're going to walk through all of that, and at the end of the day, at the end of the episode, we are going to get this beautiful structured table which contains all of the data extracted from the financial statements that are in these 10Qs and 10Ks, so that I can use it with my agents to feed my models and to do analysis. So that's available algorithmically now rather than just being trapped as unstructured data in those reports. So let's dive into it. All right, here is the code repo. I showed you a couple episodes ago how to set these up in Foundry. Code repos are fully managed Git environments, Git repo. It also comes with GitOps out of the box. So I can do all my branching in here. I can issue pull requests. I can do pull request review. I can set up my branch settings if I want to protect branches, force particular workflows, et cetera, et cetera. And also when I submit a PR, anything in the test directory is going to get run automatically, so I can prevent merging until all tests are passing. So like you got this integrated environment with Git and GitOps, so amazing stuff. But what we want to focus on today is AIP Orchestrators, and that's this package here that I'm importing that contains some really useful tools. They're going to make it super easy for you to, one, add executors, like the number of executors. That's done with actually with this configure package. But to also deal with rate limiting, tokens per minute, retry attempts, all that stuff that makes working with LLMs very hard and transforms when you're talking about a lot of data, right? So that's going to make it easy. So let's just dive in. We're going to dive into the code. Before we do that, I'm just going to run you through the AIP Orchestrator documentation just to kind of ground everyone in exactly what this library is, what it does for you, and how you can actually use the documentation to create your own transform that incorporates orchestrators. All right, so here's the docs on AIP Orchestrators. As you can see, they come with some rate limiting capabilities, the ability to distribute the workload in Spark appropriately so you can get better performance, and then also has some error handling. The number one thing you want to watch out for here is just to make sure you have the right versions of the libraries installed. You already need this Palantir Models library along with Transforms API or AIP, and you're going to need to make sure you have the right versions. Like sometimes when you install these things, they might not have the right version attached. To install the libraries, just use the libraries console in your code repos, or you could edit the dependencies in your condas file. But I typically will always use the online IDE to install packages. Just makes it a little bit easier in integrating with Gradle and everything else that's built in here to just install this stuff here. I will show at some point how to work locally here. So you can clone this repo, edit this code in VS Code, run all the local dev setup, get all the packages installed. We'll run through that at some point, but for now we're just going to focus on using the online IDE. So again, make sure you have the prereq packages installed in the right versions. We're going to jump into an implementation I did for text. Basically, this is going to be really easy to follow along if you've done any of this kind of programming before, but the first thing I'm going to do is just add my output declaration. So let's say output data set. I'm going to add my input, which was the input data set from the previous episode where I added the base64 encoding and then outputted the complete data set called SEC filings with all the additional data I needed for this use case. Then I'm going to specify the model I want, right? And so this is going to be GPT-4. I'm going to go ahead, when you specify the model GPT-4 Turbo in this case, you do have to import these. So like it will ask you to import the model when you actually set up. Like if we come in here, you can see that I have a bunch of these imported, but if I select one that needs to be imported, it will just automatically import it for me, right? And so those are the models available to me. You'll notice I have more models than Pipeline Builder. There's a lot more models available. I can even configure more models than what's currently here using the AIP, I believe it's the model catalog. And then in the control panel, I can enable different models so that we could actually see those in here. So just a heads up, you need to import the model before you use it. And then these all become parameters, right? So like here are the parameters to my transform. I've named them here. They're just going to be passed through along with this context parameter. And that is a very useful parameter. It's where you can get the Spark session and other stuff you need related to the context in which this transform is being executed. So you always add that parameter in there. And then it'll be fulfilled by this transform decorator, which is part of Palantir's Transforms API. So you can see that here. Cool. So my prompt to extract, pretty simple stuff. I just, basically give the model a persona. It's a single prompt. I tell it which type of reports we're going to be parsing. So if you watched the previous episode, you know that I categorized anything that had financial data on it as one of these 5 possible options. That's now embedded in the input data set. So if we look at that input data set real quickly, go ahead and take a look at it. As this loads, you'll see that I have categories and I have the type of statement in this array. But you can see here that we've went ahead and categorized everything. So all this metadata is already available to me in this data set. And then I'm going to go ahead and assert, basically, like, I'm going to tell it, how do you categorize things like assets and liabilities? So I'm basically telling it, look, categorize anything that's a liability, anything that's an asset as a credit and anything that's a liability as a debit. So that's like how my end data set's going to work, is like kind of generalizing across income statements, balance sheets, etc., as to just into this bucket of, hey, things that put money in as a credit, things that take money out as a debit. And I do that for revenues and expenses, and the same thing with and I just basically tell it and so on. So like it gets the idea of what I'm going for here now. And then I also tell it the JSON structure that I want outputted. So we are going to output JSON, and that allows us, which I'll show you in Pipeline Builder, to destructure that JSON and represent the output as new columns. Right? And there's other ways to do that. I just chose to do it this way. It makes for a better demo in going from code authoring to Pipeline Builder and showing you how you can kind of combine these two things for the best of all worlds. All right, and then I just dump the actual input data. So that's where the start data. After that, there's going to be the actual data from the report page that we're putting in there. Important to note too, like this is done for each page, where the category is it's a financial statement, right? So like if I see that I've taken all the pages that are going to be of this category financial statement that's in this data set, and they're actually going to be sent to the model, right? And that's where I'm doing this filter. So I'm basically just filtering the data set where anything is financial statements, or this this artifact financials statements. There was one row that had that in there. So I just made sure to catch anything that had actual financial data on it. This limit here is for testing. So like if I'm just testing, I'm going to comment that in to just limit myself to one row rather than processing everything. And then what we're going to do here is we're just going to set up the question prompt. And so I create this column called prompt, and then it's going to be the literal value of my base prompt plus the page text, right? And that's where this part here, this is the last part, that'll actually, right after that will appear the actual page text from the document, right? And so that input page text was extracted, you saw in our previous video, using AIP, and it's got the contents of the page, all right? And so the next thing we do is we're going to go ahead and use orchestrators here. And this is going to set up all that rate limiting, handling, and token management, tokens per minute, etc., and retries, and all that just completely obfuscated away. Now, I do have a custom version that I'm going to show you in a future episode that we're going to build all that from scratch so that we can call models that are not included in AIP, right? So right now, the only way I know this works is with AIP supported models because it's wrapped in their APIs, but we can actually do the same thing, and we can do it with Omni, which isn't part of AIP to my knowledge yet, or any other model you might have access to. And we'll just do a native API integration, and we'll include these same things, the same rate limiting capabilities, etc. And I'll leave that code for you. In fact, I'll leave all this code open source in GitHub at some point, so you'll have all that. So we'll show that in a future episode. But this is great to just have this out of box, man. It like saves you so much time having to stumble through building this yourself. But I will show you how to do it from scratch yourself. And then the next thing we're going to do is we're going to go ahead and include the answer columns. We're basically just setting up the completions. I'm telling it, hey, here's my question prompt. Here's the prompt column along with the answer column, right? So it's just setting up the completion, and I'll get back answered, right? And then I'm going to define the JSON structure here as a schema. So this is like the output format that I want my structured data in. And then I'm going to go ahead and once I've got my schema defined, I'm going to explode parse the JSON, load the JSON from the answer. But the first thing I have to do is unwrap it with that those shitty markers that these models seem to be incapable of not supplying. And so what we end up doing here is we just strip out the markers for the JSON and grab the clean JSON. And then we actually load that, right? So we call from JSON against the clean JSON. And I pass my schema. So at that point, I've got this structured column that contains the structure I asked the model to build, and it did successfully build all that. What's amazing is how good these models are at being able to represent the structured data from a gobbledygook of text. Like to us, if you were like trying to read through some of this text, you wouldn't be able to believe that a model can like parse this, but they're very good at this for some reason. I'm not exactly sure why. I think it's just because they understand how all the words relate, that they're very good at just taking this giant blob of text that's got all the commas in the right places and like figuring out how to map it. And so I did get 100% hit rate on this, did extremely well. It's what I ended up going with over Vision. And I'll tell you about that in a minute. And then the next thing we're going to do is just select the columns we want included in the output. And then I just write the data frame, right? And that writes my output table. All right, so the output is right here. This is the actual output from the model or from our pipeline. And you can see I got this nice struct column with the report data in it. You can preview it if you want to. But when I spot checked it, everything looked really good. I was like, sweet, the model figured everything out. And for the most part, I was really shocked with the model's ability to properly parse all of this, right? So that's AIP Orchestrators for text. It's what I went with in this example. It did way better than Vision, and I'll show you that in a sec. And then once I got this table, I went back to Pipeline Builder. And you might be asking yourself, like, why did you go back to Pipeline Builder after writing all this code? Why don't you just destructure the JSON here and have one pipeline? And the answer is debugging, right? So like even just little shitty things like unpacking the JSON, like I probably should have just outputted the answer and then everything else do it downstream. The reason is like any other thing you add on top of this pipeline is just a very expensive debugging process, right? So it's like when you're using LLMs in your transforms, I recommend just get the LLM response and call it a day and then verify those. I wouldn't even do what I was kind of doing here, like I don't know, even like selecting, well, I guess I'd try to strip it down to the minimal amount possible. I could have probably just outputted the string and done this stripping of the JSON markers and outputting the structure column in another pipeline and just got the LLM response. I'd probably recommend doing that. And again, the reason is cost, right? These things are not cheap. I spent $250 in a single day running pipelines. So what you don't want to do is be stuck in this developer loop of like running $10 mistakes over and over and over again. So like what I recommend when you're working with LLMs in your extraction pipelines is build an orchestrator pipeline like I just showed you, so you can take advantage of all of the features around rate limiting and token constraints and retries and errors, but limit it just to your LLM operations. And then you can, pick up this data in a separate transform in code or in Pipeline Builder. We're going to go ahead and pick this output up in Pipeline Builder. I'll show you that in a sec. But before we do that, let's just jump in real quick to the computer vision example. All right, here is our computer vision example. Very similar to the text completion example, except we are going to be using this multimedia prompt component input along with this language model, the GPT-4 with Vision model. So you got to remember for sure you got to use this wrapper for the Vision Pro model, which is also one of the AIP models included in AIP from OpenAI. And very similar setup as before. I'm specifying my rate limit, my token limit per minute. I'm going to go ahead and sample my data frame just like I did before to get those only those columns that contain the rows that are financial statements, right? So like I'm just filtering out. I only want to see the rows that are of the category financial statement for what I'm doing. And then down here, I'm going to go ahead and set up my prompt. This is the system prompt. It's different. I didn't bring over this one yet. I will. Don't worry. I just didn't end up going with this pipeline, so I just left it, but it has a different prompt for now. Then I'm setting up the orchestrator just like I did before, right? So like here's the rate limit, tokens per minute, here's the model, the properties for the model. I set temperature to 0. I don't want it writing me poetry, so I always throttle the temperature down. And then the completions with column setup is a little bit different, right? Like in this case, I'm specifying this array here, which contains the system prompt, which I set up with this role system, and then the user prompt with role user. They're both column names. These are extracted from the data frame, so it automatically maps to columns, and then I get the LLM answer value. That's going to be where my answer from the model comes back, and then I output the data frame. So very similar, just some minor tweaks to support a vision use case. The problem was I was getting crap output, and I suspect it's because when I looked at the images themselves, when I took the base 64 data, base 64 encoded data that's actually in this data set, and then rendered it visually, it's really low resolution, and I could barely make out anything. Granted, my eyes are shit, I'm an old man, but I could see why the model was really struggling with this, and so I would probably need higher quality resolution of the images themselves. Unfortunately, not exactly sure how to pull that off. I opened a ticket with Palantir. There is a method that when in the previous episode where I was showing how you can create base64 encodes using media set inputs, the method I use does take a height and width property, which appears to be scaled down quite a bit from the source. And so I'm open to take it with Palantir to see if I can figure out how can I supply the native height and width or a much larger height and width to that function so that I get a higher resolution base64 encode. So when they get back to me with an answer on that, I'll go ahead and finish testing the vision use case. But honestly, the text worked perfectly, right? So like, I don't even know why I would use vision. It's going to be slower. It's going to be more expensive. I have less options for the models. Just use text is my advice here. Totally counterintuitive finding, by the way. I thought for sure vision would outperform. But at the end of the day, freaking... the output I finally ended up getting was perfectly, it was 100% spot on just using the text. So I don't think you even need vision once you've gone and extracted the text from these PDF pages, unless there are going to be, I'll show you at some point if I get a good sample of documents, maybe some prospectus from some funds where you are going to need a vision model because the text is just, there may not even be text on the page to begin with. A lot of it might be look like marketing material. So we'll take a look at some prospectuses and stuff like that where vision will be required. But that's it on the code authoring. Next up, we're going to jump in. And by the way, be sure to check out Orchestrators if you're building these kind of integrations in code authoring. It's going to save you a ton of time. Anytime you're doing batch processing with LLMs, you're going to want to do this. So next up, let's take a look at Pipeline Builder, where I destructure the struct column I created here and finish up with our output. All right, last one. Here we go. Back into Pipeline Builder. This is the output of the previous data set I just showed you. All right, looking good. Fortunately, what we got to do is we got to destructure this column, right? It's a JSON struct, and that data that's in there isn't doing me any good right now. What I want to do is get that into an exploded flat structure, which I'll show you the output again. So to do that, I just use Pipeline Builder. You can come in here if Pipeline Builder has a get struct field, and from there you can just specify the column holding your struct data, and you can specify the locator, and it automatically populates that locator for you. If you were to click in here, I'm already taking all the destructured fields, but it'll list them for you, and you can just select the one you want to destructure. Did the same thing. You just keep doing that. Then I got to explode arrays, right? So like I use the explode array with position function. That gives me both the array elements plus their position, which you're absolutely going to need to reassemble this data. And so we go ahead and do that for both the rows and the headers. We get the exploded positions, et cetera, et cetera. Then I destructure all of those values. At the end of the day, I drop all the crap I'm not interested in anymore, and I get this beautiful data set, which you're seeing previewed down here below, which is my output, right? And that is the flattened data structure for all of the reports that are in the 10Ks and the 10Qs and all that stuff. In our case, we're just looking at the 10Q, but I will show you in a minute. The next episode probably we'll start getting 10Ks in there, and we'll do a bunch of them. We'll get this data outputted. So here is all of the wonderfully structured report data fully exploded, flattened, and now we can use this if we want to do data science, or if we want not necessarily data science on this data, but if we want to feed models, right? There are formal models and methodologies to evaluate the quality of an income statement, the quality of a balance sheet. Now with this data, we can actually feed those, because some of those analyses require specific line items as input from the income statement and the balance sheet. And guess what we're going to use to do that mapping? Yes, you guessed it. We're going to build LLM agents that leverage the power of these LLMs to map parameters into formulas, right? So I'm not going to let an LLM try and do the analysis for me. I'm going to have the LLM map from these data sets the appropriate input parameters to a formally coded function that will do the analysis, right? Because that can be well-tested engineered code. All I'm asking the LLM to do, essentially marshal the inputs and assemble them in the right order to achieve a task, right? Much easier problem to solve. So stay tuned. Next episode, that's what we're going to be doing. We're going to be building some actual agents that analyze this data for us and give us some answers, and we're going to scale. We're going to scale up. We're going to add SoFi, right? I know you guys love SoFi. Maybe we'll add Rocket Lab, right? Tell me, leave in the comments what companies, 10Ks and 10Qs, hey, it's on me. I'm going to be using my credits. I'll burn my credits so you don't have to. We'll start analyzing those things. Maybe we build this thing up into something that you can all actually use, and it's a relatively useful tool. You could maybe even log into my Foundry instance and take a look at this data and use it in your own decision making. So stay tuned. That's what's next. But I was extremely impressed with the ability of the model to find all of this data that's on the page, put it into the format that I was asking for. Very impressive stuff. And I have no doubt that when I combine XReason, which is my reasoning framework, with this inside Foundry, and you get to see that happen, we're going to answer some pretty cool questions. So stay tuned, and I'll see you guys in the next episode.